Okay, Unit 4, Identifying Congruent Triangles, Section 4.1, Classifying Triangles. Our objective is students will successfully identify the parts of triangles and classify triangles by their parts. First off, we need to define what a polygon is. It is a closed figure in a plane that is made up of segments called sides that intersect only at their endpoints called vertices. Now, our triangle is a three-sided polygon. To name a triangle, you use the triangle symbol and the three vertices of the triangle. So, for instance, this triangle here would be called triangle ABC. You could also call it triangle BAC or triangle CAB or triangle CBA. Okay, just the three corners. An acute triangle is a triangle in which all the angles of the triangle are acute angles. And as a reminder, acute angle means less than 90 degrees. So for example, this triangle, we have a 45-degree angle, a 75-degree angle, and a 60-degree angle. Those are all less than 90, so that triangle is an acute triangle. Okay. For an obtuse triangle, it is a triangle in which only one angle is obtuse. So one angle is larger than 90, but less than 180. So an example, we have a 38-degree angle, 39-degree angle. Those are both acute, but we have a third angle. It is 103 degrees, which is obtuse. So this triangle is an obtuse triangle. A right triangle is a triangle in which one angle is a right angle. Okay, there's various ways to see this. We could have it as a 90-degree angle labeled 90 degrees, or we could simply use the box. That means perpendicular, and perpendicular means right angle. So both of these triangles, triangle JLK and triangle ABC, are right triangles. Okay, parts of the right triangle that we need to know. The side across from the right angle, so your little box points at it, okay, is called the hypotenuse. Okay. The other two sides that are not the hypotenuses are called legs. An equiangular triangle. Equi means equal, angular means angle. So this is an acute triangle in which all the angles are congruent. Okay. The only triangle in which all the angles are congruent is a triangle with 60, 60, 60 degrees in all three angles. Now we're going to talk about naming the triangle by the lengths of the sides. So those first three that we talked about, or first four, I'm sorry, acute on the previous slide, obtuse, right, and equiangular, all look at angle measurements to name it. Now we're going to look at the sides to name. Okay, a scalene triangle is a triangle in which no two sides are congruent, or in other words, none of the sides are congruent. Okay, so for example, if I have 3 for the side, 8 for PR, and 10 for QR, these three sides are different lengths, so none of the sides are congruent. So triangle QPR is a scalene triangle. An isosceles triangle is a triangle in which two sides are congruent. Okay, so I have TS being 5 and TU being 5. Okay, another way to show it is our congruent marks. I have marked DE and EF as being congruent, which means two sides are congruent. So triangle DEF is also an isosceles triangle. The non-congruent side is called the base on an isosceles triangle. So we learned last unit that rotating was okay. If we turn this triangle DEF sideways, the base would still be DF. Okay, your elementary school teachers did not lie to you about the base being on bottom. They gave you pictures that had that base on the bottom always. They did not turn the triangle at all. Okay, but now that we're older, we can go ahead and turn that triangle and call the non-congruent side the base. Okay. The congruent sides, those are called the legs. So over here on triangle STU, the base would be SU because it's the non-congruent side, and the legs would be ST and UT. Okay, base angles. The base angles are formed by the base and one leg. The base and one leg. Okay, so angle D and angle F are base angles. Over here in our first triangle, we want the base and a leg. So angle S would be a base angle. A base and a leg, angle U would be a base angle. Vertex angle is the angle made by the two congruent sides. So angle E is the vertex angle. So in this triangle, our two congruent sides are ST and UT. So our vertex angle is angle T. An equilateral. Equi, again, means equal. Lateral means sides. So this is equal sides. So a triangle in which all the sides are congruent. Okay. So since all sides are labeled 7, triangle VWX is an equilateral triangle. All right, we want to find X, the measure of RS, the measure of ST, and the measure of RT using the picture below. So sometimes on these problems, you have extra information and you have to process which information you use and which information you don't. So when we are solving for X, I don't need to know what ST is. I do have that SR and RT are congruent, so I could take this 7x or x plus 7 and 3x minus 5 and set those equal to each other. Okay, and now I can solve for x. So I'm going to subtract x from both sides. I'm going to add 5 to both sides, and then I'm going to divide by 2, and I got x equals 6. So that's the answer to this. Now I have to find these others. So RS is x plus 7. So I'm going to plug in 6 for x. So 6 plus 7 is 13. Now, I don't want to do more work than I have to. Remember, RS was congruent to RT. So I already know that RT has got to be 13 also. Now for ST. ST was equal to x minus 1. So I need to plug in my x, which was 6. So I have 6 minus 1. 6 minus 1 is 5. So ST is 5. Go back up and double check. I did X, I did RS, I did ST, and I did RT. So I answered all the questions. Okay. Given our triangle DAR with vertices D at 2, 6, A at 4, -5, R at -3, 0, determine if triangle DAR is a scalene triangle. So the first thing I tell students is we're going to use the distance formula, and we have to remember that, and to sketch a picture. It does not, and it cannot be on, or it can be on coordinate grid, but that's not enough graphing it. You have to actually find numbers, okay? So we're going to do the distance formula to find the length of DA. So I did 2 minus 4 quantity squared plus 6 minus a -5 quantity squared. And that's just filling in our distance formula. Okay. 2 minus 4 is -2. -2 squared is 4. 6 minus a -5, that turns to a plus. So 6 plus 5 is 11. 11 squared is 121. 4 plus 121 is 125, the square root of 125. You want to take that and write it over here on your triangles so you can see the length. We are not concerned about reducing these into proper notation. Leave it as a square root. Okay. You can pause this video and go ahead and find AR and DR. Okay, AR Plugging in, we get the square root of 74. Finding dr, we plug in and we find the square root of 61. So now come over to your triangle and compare these numbers. Are any of them the same? And you should say no. So all three sides are different, and we call, when a triangle is all three sides different, a scalene triangle. Okay. If I had two of them being equal, then I would call it an isosceles. If I had all three equal, I would call it an equilateral triangle, because again, we're naming it by the sides because we're doing distance formula on the lengths of the sides. Okay. The second part asked us, it did not ask us for this, but we'll do perimeter. It asks us for perimeter, so we just have to simplify and add those together. Okay. Go ahead and take a minute and answer this question. What is the difference between an isosceles triangle, a scalene triangle, and an equilateral triangle? Okay. An isosceles triangle has two sides congruent. A scalene has no sides congruent, and an equilateral triangle has three sides congruent. Your homework is 4.1 Classifying Triangles worksheet.